Hi, everyone who's called in so far. I'm just going to give it just about one more minute to let people dial in, and then we will get started. All right, welcome everyone to our webinar on building resilience, future-ready strategies for natural disasters. As the world transforms at an unprecedented rate, driven by climate change, technological innovations, shifting societal expectations, and resource challenges, organizations face new risks and challenges every day. At WSP, we believe that understanding and mitigating these changes isn't just important, but it's essential to building resilient, future-ready solutions for our clients. Our Future Ready program is grounded in the latest research on 24 transformative megatrends spanning from climate, resources, society, and technology that will shape how we live, work, and thrive over the next 30 or so years. By identifying the risks and opportunities most relevant to your sector, we help you turn uncertainty into strategic advantage, embedding resilience and innovation into every project. We don't just talk about the future, we help you act on it. Our evidence-led approach combines global expertise, local insights, and real-world case studies to deliver solutions that are robust, adaptable, and tailored to your needs. Whether you're planning infrastructure, designing healthcare facilities, or managing digital assets, our teams bring the foresight and tools to help you stay ahead of the curve. We've designed today's session to spark dialogue and collaboration around a few key services that we offer to our clients. We will invite you to ask questions and share your own perspectives or expertise, so together we can build a future that's not just resilient, but ready for whatever comes next. My name is Emily Miranda, and I will be today's moderator. As WSP Canada's Future Ready program lead with the Registered Professional Planning designation, I help raise staff awareness on relevant industry megatrends and work with them to develop actionable strategies for their clients and projects. Now let me introduce you to today's experts. So we have Jonas. He is a climate consultant with an engineering background, advising sectors like transportation, energy, and government. He leads a national advisory practice at WSP consisting of technical professionals who have decades of experience in meteorology, climate resilience, information and data management, remote sensing, and instrumentation. We also have with us Kevin. He is WSP Canada's National Market Lead for Healthcare and Science and chairs the Global Healthcare team. With over 20 years of experience in designing a wide variety of healthcare facilities, Kevin specializes in planning, compliance, and project delivery. He is passionate about creating innovative environments that support best care practices and works closely with clients and partners to address the unique challenges facing healthcare today. Furthermore, we have Mark. He is the co-founder and CEO of UrbanLogiq with extensive experience in government and AI. He's presented internationally on the future of government, holds 3 pending AI patents, and leads UrbanLogiq in ensuring their platform translate government challenges into scalable and predictive solutions. Last but not least, we have Michel. He is WSP Canada's National Market Lead for Data Centers and Mission Critical, bringing over 30 years of experience in executive roles within the data center and IT industry. He specializes in designing and operating data center solutions to meet growing infrastructure demands and has overseen large major IT facilities across Canada as well as internationally. Michel holds a Bachelor of Engineering from Polytechnique, Montreal, and serves as a data center dynamics trainer for North America. Now we'll be transitioning into our session where our experts will share their perspectives. Following this, we'll be opening up the floor for our audience questions. So my first question to all of my panelists here today is, natural disasters are really intensifying and becoming part of our new normal. From your perspective, what is the largest gaps you see today and how organizations are preparing for these risks?
I can kick us off. Something that we encounter on a regular basis is organizations assuming that publicly available information is the best or the only information that they can use to base their decisions on. Each organization, public, private, big, small, they all have unique sensitivities. They have unique resources and decision-making processes, and all of which tend to evolve over time. And having a team of decision makers discussing which of their favorite apps or websites is the best is valuable time that could be spent preparing and responding to the risks at hand. They're missing something that's fit for purpose.
Awesome.
And I'd say, building on that a little bit too, a lot of what we see in that healthcare space is this risk around preparing within the bubble, or really only knowing what they do know as an organization. So we design a lot of healthcare infrastructure, as an example, to be resilient to things like earthquakes. It's actually baked into codes. And so that infrastructure on that site could be resilient, but what about the infrastructure that's leading up to the space? What about the roadways and the pathways and the supply chains that are, these organizations need to rely on in those natural disaster situations? So it's really something where people are planning things, but they're not necessarily planning with the community around them. And so there is a risk there for sure around how you're going to be able to withstand that disaster for that prescribed period of time, unless you're having those conversations.
Yeah, I'd build on that by saying, I think Emily began this by talking about how there's this explosion of data, and we're all talking about the age of AI. But one of the challenges is that we're in this weird paradox. I used to come from government, and governments are collecting, and societies and businesses are collecting enormous amounts of data. But if you sit down with the average public servant or business leader and say, what do you personally have access to? That data is either siloed somewhere else, or in these attempts to centralize data, putting the data in one place is not the same thing as being able to understand how each piece of information is relevant or related to each other. So I think that's one of the challenges is having more and more data is not the same thing as producing more and more insights. And the big gap right now is being able to take the different data sets and domain expertise and fusing that together so that there's a complementary compounding effect of understanding. And I think that's a lot of what we're going to be talking about today, of where WSP and their partners are heading down in that direction.
Yeah, absolutely right. And the thing is, with data, what we have when we're designing data centers, we're focusing a lot on ASHRAE type of standards, or the type of standards for the floods and so on. But as you all know, we have the 100-year flood every year now, and we have skyrocketed temperature of 50 degrees Celsius like we had in Vancouver a few years ago. So designing to the standard of ASHRAE, which is revised every 4 years, okay, is not a really good way to go. So using data like we publicly, or the ones that WSP can provide you with, is quite interesting. And some of our customers are already doing it. What they're doing, they're going to take the maximum 20 years of ASHRAE plus 5 degrees Fahrenheit. So which helps a little bit. But for me, it's not, if it was only for me, I've designed everything to 50 degrees Celsius. That's different. But we need to accommodate and get out of the frame that we had, that standards are the best way of designing. They're a good frame, but we need to apply more things around it.
Wonderful. Thank you all for that. That is very informative and a lot for us to unpack with some of our next questions. So Jonas, I'm going to put my next one to you. One of WSP's strengths is foresight. So using tools that anticipate what's coming. Can you introduce advanced weather intelligence, or is what we call it here AWI, and explain how it supports clients in anticipating and responding to extreme weather events? And if you can add some case studies to support this, that would be very appreciated.
Yeah, absolutely. I love talking about advanced weather intelligence. So AWI goes well beyond basic weather forecasts. What we really provide is operations and risk management tools. They're designed specifically to meet clients' needs, and that's something different for each client. Whether they're a small town, a complex industrial operation, or a provincial or state government. By combining real-time intelligence, predictive analytics, and 24/7 expert support, AWI provides clients what they need, when they need it, and in a format that is most useful for their decision-making process. Ultimately, we enable them to make confident decisions quickly. Now, what we provide can look like anything, from a detailed breakdown of what to expect in the coming hours and days, to an animation of how asset-specific risks will evolve in space and time, to warnings and alerts you get on your phone. Could be a live weather briefing from a professional meteorologist, either virtually or on site, or just a data feed that ties directly into a client's control room. And this is just to name a few examples. Now, there's a couple specific use cases I'll briefly mention to give you a better idea of the decisions our clients are faced with and the consequences of those decisions. So at a local level, we support school boards that make decisions all the time that impact the safety of thousands of children. Schools opens, close, delays, early release, and anyone with school-aged children knows that those decisions have broad-reaching impacts into the community. We support municipalities that need to effectively deploy their often very limited winter road clearing resources. This impacts things like the mobility of emergency vehicles, the ability to access healthcare facilities and shelters, or even just workplaces and stores in general. We also support energy and utility clients. They have broad-reaching infrastructure across diverse geographies, and it's sensitive to things like geomagnetic interference and lightning, and they have field teams deployed all the time that they need to keep safe. And in addition to maintaining a reliable supply of electricity, they also need to know how demand for that electricity is going to fluctuate in the near term, in order to keep their costs low and clients' costs low. And we support them with all that. So you might be getting the idea now that we have a pretty diverse set of clients, and since everyone is impacted by weather, each in their own way, and our team at WSP is the largest provider of weather intelligence in Canada. On a daily basis, we process close to 3 terabytes of data, including over 4 million real-time sensor readings from public and private networks, and we distill that into 80,000 different forecasts delivered to over 17,000 users, all of whom use our intelligence to regularly make weather-sensitive decisions.
Wow, that's a lot. So kind of expanding or in relation to that, Mark, there's a lot of online discourse that's underscoring the significance of predictive intelligence. UrbanLogiq, I feel like, takes that a bit further by mapping risks in space and time. Can you share how your platform helps clients strengthen their planning and response, as well as how the WSP UrbanLogiq partnership is bringing value to our clients?
Yeah, very happy to. So the best way to understand what UrbanLogiq does is we build a high definition digital twin of the planet. So we take data from federal, state, provincial, county, local governments across 8 dimensions. So transportation, economic development, urban planning, demographics, businesses, land, infrastructure, weather, events, mobility, and economics. We fuse that all into one central corpus of data. And then we use machine and deep learning models to identify how different features in a community impact and have a causal relationship with others. So once we have that picture of what composes a community from people and businesses and infrastructure, and when weather changes, how does that change the behavior of people? How does a change of human movement impact businesses, et cetera? We now have a high definition understanding of communities. This is the important part where understanding that artificial intelligence is not like regular software engineering. You don't program it as so much as you teach it. And one of the things that's exciting working with WSP is think of WSP as providing some of the world's best tutors to this AI system. So what we do is we put all this data in one place and we bring in the scientists and engineers and consultants of WSP to say, how is this, how do you provide insights of value to the community? So some concrete examples. I'm actually right now in Boise, Idaho at a WSP office, and we were working yesterday with WSP engineers who are experts at power systems. So we're looking at, for example, this is where we worked with Jonas and his team to understand how different scenarios of climate change are going to create different demands on power systems as air conditioning demands, et cetera, increases. And then what we're going to do is we then look at features of geotechnical risk. So you might see in a certain community, based on climate change projections, they're going to need 8 more power, or 2 more power transformer locations. There might be 8 locations where they're looking at buying land. Now, this is where the sophisticated spatial dimension comes into play. There might be, these 8 places you can buy land for these transformers. One of them might be on paper really cheap, but when you project how climate change is going to increase the risk of landslides and floods, you're going to be spending the next 50 years mitigating those risks. So what WSP can do with this AI system is create a total lifetime cost of every site location and get a more climate-informed, contextual understanding of the full price you're going to pay for a given asset. And you can do this within seconds. So that's an example on the temporal component. On space, for example, on hospitals, one of the things that we've worked with WSP to do is to create a risk profile of every facility, for example, healthcare facility across Canada. And it's not just, this hospital is at risk. What also is its connection to the community? So there might be landslides that you're evaluating where's more important to put in mitigation. One road feature, Michelle talked about, you have these 1 in 100-year events happening more frequently. So there might be a road that it's more likely to have a landslide. Do you prioritize that? Or this other road, the likelihood of a landslide is less frequent. However, when we have 14 million data points a day of human mobility. And when you look at that, you can use that to identify that this one road segment is the only point of access to hospital for this neighborhood. So then you can identify this as a single point of failure that under no circumstances can ever fail. Those are the types of insights that leads to a more nuanced understanding for communities to understand their risk profiles.
You led me in nicely to my next question, leading to Kevin. So where are you seeing the greatest opportunity for healthcare clients to shift from reactive emergency management to being more proactive? Just exactly as what Mark was speaking to, and hopefully it didn't take too much of your thunder.
No, and it's a really good question, because there's always going to be disasters and situations that come on that are going to be reactive, right? Chemical spills, or say a nuclear event at a power site where you're now reacting to that disaster that's impacting a smaller group of people, right, that are coming into your ER, or coming in to use the health system. Where it can get a bit more proactive, I think, is in things like climate change related disasters. And so there's going to be reaction that's necessary, that's an operational reaction. So, a good example of this are the heat domes in Vancouver. Heat domes, we know for a fact, are one of the most deadliest of, when you think about extreme weather, one of the most deadliest types of extreme weather. It by far outstrips anything else, including hurricanes and floods, as far as a human death toll. And so knowing that that's coming, knowing that there's going to be an impact on people in your community, you can prepare for those surges that are going to come into emergency departments. But you can also, hospitals can also take an opportunity to get better communications with their municipalities and work with the community to go and reach out to the populations that we know are going to be impacted by that event. The elderly, people that are living on their own, communities where there might not be a large amount of infrastructure that allows people to escape that heat. But it also allows them to be proactive as far as their infrastructure is concerned. So those 1 in 100 events that Michelle's talking about, a lot of the new hospitals that we build, we design those to be resilient. We put things like generators on upper floors. We make sure that we raise that infrastructure up so it's not impacted by floods. We seismically restrain things so we know that earthquakes won't impact them. But the reality is that there's about 300 existing facilities in Canada across the country that were not designed to those codes and standards, right? Where infrastructure was placed in a basement, sort of out of sight, because it was taking up valuable space on upper floors if you didn't put it down in that basement. So those facilities definitely have an impact. So knowing and understanding with real weather data what the chances are of that 1 in 100 flood event, actually maybe it's really a 1 in 10-year event now. What is your plan? Do you have access to funding to be able to reinforce that infrastructure and change the way that you're currently servicing your building to be able to withstand those events? It's important. So, that's important. It's also important to have discussions with your insurance companies. We're seeing a lot of insurance companies now driving a lot of this need to raise the infrastructure up, because it's getting reflected in premiums as well. So understanding what your infrastructure is, understanding what the impacts are to that infrastructure, and then being able to actively do something about it is key for our health infrastructure.
Great, thanks, Kevin. Michelle, how can we leverage our available data? Because we were talking about that before, about how much there is out there and where it's coming from. But how can we start leveraging that data to effectively inform data center operators who are involved in the development of industry standards?
And it's funny because all the AI and the data are housed in the data centers itself. So you want to make sure that the data centers don't crash for the AI don't crash. So, the thing is, what we're lucky is that resiliency and redundancy and standards to overcome floods and things like that has been part of the data center world for at least 30 years. If you take only the TIA 942 that came out about 28, 7 years ago, the first one, we had distance from airports, gas station, train station, risk of highways, and so on that came into where to build the best data centers. Of course, there's no such thing as the best place, because if you're in the middle of nowhere, there's nothing going there, no power, no telco, so we had to compromise. But it's always was always in the back of our minds when we were designing. The major things we're facing is operation and trying to cope with what's coming. Because we are redundant, we can do maintenance, we are in most cases even fault tolerant, and we've been having our generators out of the basement for years and years and years now. And it's so funny when you see floods in, not funny in a funny way, but when you see floods in New York City hitting and you see the waterfalls getting to basement and you see generators on the water, it makes me cry almost. And so heat waves are quite local, so we need to understand that exactly. And operation-wise, a lot of data centers have multiple type of cooling infrastructure in there. So some of them would use fresh air going inside. Some of them will have cooling towers, and then run according to humidity also, dry coolers, temperature. Some of them we have sandstorms depending where you are. So we need to be able to prepare our infrastructure according to what's coming, and gathering those data is the perfect way to do it. And keep in mind that a good data center is always designed to be standalone. Beside the connectivity of the fiber outside, we don't require power, we don't require water, we don't require anything else. We can live by ourselves, totally isolated, except connectivity. This is why we have multiple redundant fibers going to. And regarding the major events coming in, we have something unique by if you're having a lot of data centers, we can be redundant one another, what an hospital can be. So it's pretty hard to move your patients from one hospital during surgery from one hospital to the other. While my data, if it's being jeopardized because something is coming, I just can transfer it to another data center. So we're building in what we call triangle. So in 3 different type of earthquake zone and even climate zone, and with double or triple fibers between all 3s, so we can create a perfect redundancy. So that's becoming more and more a standard, and that's what Google and Meta and Microsoft are doing. So they have redundancy within, but they have redundancy to protect their data itself from outside. So using all the weather information is critical locally, but it might become extremely critical. We'll transfer our load, our IT load, elsewhere, just in case, to prepare.
Awesome, thank you. So Jonas, coming back to yourself, if we want to shift all of our questions now to more like that emergency response and continuity, during an unfolding disaster, how does AWI support clients in keeping critical services and assets operational?
Well, I find it really interesting how integrated everything really is. Because we, first and foremost, we have to ensure our own services are resilient. Like, we can't help clients if our services go down.
Yeah.
And so, all of our digital infrastructure is cloud-based. Like everything that Michel has just outlined contributes to our ability to deliver for clients, regardless of what the conditions are. And then within our own coding and systems, we have different redundancies and fail safe. So it's extra layers and layers upon layers. And another layer upon that is actually where our forecasters, our professional meteorologists are based. We're very geographically diverse. We have forecasters, I think, in about a dozen different geographies. From St. John's, where I am, to Victoria, down to Florida, and that's been really important. And I'll give you two two really good examples of why that's been important and why it's really helped us be resilient in the past. Several years ago, there was a tornado that went through Ottawa, and it actually hit our weather center in Ottawa. And so, our non-Ottawa forecasters, jumped online, and they were able to, continue providing services. And most of our clients aren't in Ottawa, so they might not even be aware that something like that's happening. And then in 2000, we had in St. John's our Snowmageddon. And that was almost a meter of snow in 24 hours, which put the entire city into a state of emergency for 8 days. Having a lot of our forecasters not in St. John's made it possible and this was before COVID. This was before we had fully transitioned to being able to do remote work. So we still had those resiliency measures in. So there's a lot of people that get called in when they weren't on shift, but they were able to work as a team and still provide forecasts for the city of St. John's as well as all of our other clients. So our own resilience is the first step. But focusing on clients, many of them have the appropriate level of type, level and type of service already in place well in advance of an event. Like they go through a proactive process where they evaluate what would be useful or kind of what their sensitivities or insight is going to be needed, and things that we provide are like storm reports and prepared briefings, local and regional forecasts, real-time data feeds and visualizations. But we're also able to ramp up the type and frequency of services that we provide. So we can modify alert thresholds. You can have forecasters on standby, 24/7 to provide insight into the nuance of evolving environmental conditions. Because what's expected in advance of event is probably going to be a little bit different than what's happening during event. And we can also let them know when most of the danger has passed and what they're going to be facing weather-wise during post-event recovery.
Awesome, thanks. So now, Mark, if we want to go beyond forecasting, how does your platform provide actionable intelligence to municipalities, healthcare providers, or even data centers during a disaster?
So I think the most important thing is understanding the nature of a community from a holistic dimension. So, for example, one of the things that we've talked endlessly with a number of local communities in postmortems after things like wildfires, for example, is I'll take a community in BC during the wildfires. If you think of the different players and jurisdictions involved, you have the federal government who will come in with the 39 Canadian Brigade Group. So there's the Army, which is federal. Then you have the provincial government with the BC Ambulance Service. Then you have the local fire department. They all arrive the same place. Do they have the same maps? Do they have the same understanding of who's going to be deployed where? In one community, for example, they're the home of a very large pipeline and oil farm. So a lot of their thinking is we're going to need to send firefighters to that area. Do you know that private company might have a fire department bigger than your cities? Because this is an asset that they had to invest in. And then similarly, when they're looking at evacuating populations in that wildfire situation, how do you coordinate when the local roads are on my municipality, the highways are provincial and federal, and yet the people who understand where are people at this exact moment might be, a TELUS, for example, with location-based cell phone data. So these are all the things where everyone is sitting on an essential piece of the puzzle. And yet what would be invaluable was if the fire department, the Army, and the private companies could all share their critical piece of the puzzle and then benefit from the insights of each other's data. So that's that common operating picture that UrbanLogiq brings when we bring in like federal, provincial, local, and private sector data. We fuse it in a way. It's a little more common putting all the data in one place because oftentimes you might have a camera, from a traffic sensor and a cell phone. Are you counting the same person twice? There's lots of these things where there's a lot of work you have to normalize and structure the data so that it is providing you an actionable insight. And then you can't just let AI run wild. You then have to bring in domain experts who understand human behavior in the event of an evacuation. Bring in fire behavior experts who understand because of the topography here, the fire is actually going to leap over here next. And you're all looking at this area here. You need to be evacuating these people first. And by the way, if you have high definition demographic data in certain areas of the community we looked at, 2/3 of the low-income people there can't afford cars. So when you give an evacuation order, what are you going to do with those low-income seniors? You know what you have? You have a school board that owns a fleet of buses. All these are things where everyone has an essential piece, but you have to work together as a team. And that's the nexus that UrbanLogiq builds a platform so that everyone can bring their piece of the puzzle, a piece of the solution of the puzzle, They can all benefit from the consolidated view and understanding with what we jokingly refer to as the adults in the room, where you bring in actual domain experts who can consume this information in a responsible fashion.
I really wish that Manitoba had that this summer when they were dealing with their wildfires, because there's a lot of discussions around how a lot of people that had no access to cars, or there's also just that overall essence of I've been through it before and I just don't want to leave because I know I can stay, or they just had accessibility concerns. So that actually kind of brings me now, Kevin, back to yourself. So we talk about people, or I just mentioned like how people have accessibility issues and can't get from one place to another. And we've also covered how a lot of the services that each of you represent here today are a key element to our puzzle that needs to stay active during a disaster. So, and hospitals are one of those lifelines that need to be operational through and through. So how are you designing healthcare facilities to remain functional during these extreme events, ensuring patients and emergency services are protected?
Yeah, and I'm actually really loving this conversation because what Mark and Jonas and Michelle have been touching on is everything that we're talking about here is actually a small part of a really complex system, right? And so that hospital is no different, right? So hospitals, by code are designed to be resilient. They're designed to have redundant systems, right? So when we do these electrically, mechanically, we try to mitigate or eliminate single points of failure, right? So lots of different paths for communication lines, for power, for air, for medical gases, to make sure that they stay standing in the event of an earthquake or in the event of a flood. The piece that's interesting to me around a lot of this is, what if the hospital itself becomes that single point of failure, right? Where do you send patients? Where do you redirect people? How are you making sure that communication is coming out through the community so people know where to go? How is it getting to the right people in the right time? Mark, you were talking about how there's multiple levels of government dealing with the road infrastructure and dealing with the school boards. And it's also the same thing here, where we've got hospitals that generally, for the most part, are being funded at a provincial level, but you've got roadways that are coming in potentially at a municipal or at a federal level, depending on which highways they sit on. You've got assets that are in the community that could be used to actually help lift away some of that demand in that emergency situation, right? So we saw during COVID, as an example, a lot of community centers being converted into triage spaces, right? And so, with a little bit of foresight, could those facilities be designed with not necessarily healthcare grade infrastructure, but a bit more resilient infrastructure so that we can easily use them in an emergency? But those tend to be municipal assets, not provincial assets. So a lot of communication needs to happen to allow for that to occur. A lot of conversations, quite frankly, around funding and who's paying for some of this infrastructure that ultimately results in a more resilient society. But because we've set up sort of these abstract levels of funding that come in for these different assets, it actually creates a bit of a barrier of our own making that gets in the way. So, some of those conversations I think need to happen to allow the communities to become more resilient, allowing that hospital to function as that lifeline, but in a more redundant way, so that the healthcare that people need and the emergency response that people need isn't necessarily concentrated in one spot. It's still a lifeline for the sickest of the sick. It's still a lifeline from a trauma point of view, but with the data that we have access to, we have an ability to make some insights in how we make a more resilient, make the community a lifeline, right? And are able to actually adapt to those disasters in a more productive way.
I like that. Just speaking to, it's more than just that one piece of the puzzle, which just it seems to be an evolution of themes that we brought here today without purposely planning that. Okay, Michelle, data centers, they provide a lot of power to our digital infrastructure. And you'd mentioned before heat waves are the highest risk disasters for our facilities. How do you ensure that they stay online during these disasters?
Two ways, by luck and by planning. By luck used to be quite what we did. For instance, the Vancouver heat wave. A lot of customers had data centers there, and 50 degrees Celsius is not the way we design in Vancouver. It's about 30 degrees Celsius, the max we design for. And the thing is, we're quite lucky. Our customers at the time were loaded at half of their capacity, server-wise. So they had a lot of capacity in cooling to support that. So every air conditioning within the data center were running 100%, but that was not even enough. What they needed to do, they needed to install garden sprinklers underneath each condensers on the roof and spray water, potable water, mind you. They run through it. So another example that didn't go so well, 3 summers ago, London, Google and LinkedIn crashed because they had a heat wave of 35 degrees Celsius, close to actually went up to 39. So they're not designed for that. And Google and LinkedIn, being well close to their 80% capacity, just crashed. They couldn't do anything. So what becomes interesting is when we're using AI to operate, most operators will know that their capacity looking at the utility meter is at 50%, but they don't know their actual state of utilization of their infrastructure within, which is really used, which is perfectly in operation and so on. So AI help us work that and makes everything work a lot better. So we understand and we live with it, what's going through and how each and every system is working. If you take that and you use it with all the information that we get from the weather infrastructure, it helps a lot. So I'll know, okay, I'm going to be overwhelmed here in a few hours or in a few days. So let's start to transfer things before anything happens. So I can start to call my customers right away saying we need to transfer some load and so on. So it helps a lot. And AI is being implemented more and more in data center operations. And it's been this for at least 3 years, okay? And we started to see sort of intelligent data in data centers. The first one I saw was about 9 years ago. Learning how to operate, which system to start, what would be how to balance the load and so on. So it's getting better. And of course, we have all the resiliency and the redundancy required for generators, battery systems, cooling systems. And like I said, we can be standalone indefinitely. That's the design. Okay, of course, if we're bringing diesel to feed our generators, that's it. So.
Okay, awesome. Okay, well, to close out then the questions that I'm going to pose to yourselves, I'll open it up again to each of you to answer. So in light of the ways that resilience strategies can be scaled across an entire portfolio, recovery times can be shortened to protect business continuity, and effective cross-sector collaboration can strengthen disaster preparedness. What lessons can the public sector draw from private sector approaches to disaster resilience and response, and how might these practices be adapted to foster more robust, coordinated outcomes for the communities?
I'll kick off us wrapping up. So the couple quick points I want to make. One is really just emphasizing something, so re-emphasizing something that Mark said, maybe putting a slightly different way. Having decision makers at various levels of different organizations referencing siloed information is, Mark highlighted, is not the way to go. And having everybody being able to reference a single source of truth. So there's the decisions that are made, it's understood what's behind them. And regardless of who's involved in the response, they're able to access and reference that single source of truth to be able to build on those decisions that are made and kind of understand the way forward. Having that common trusted reference, saves a significant amount of time and conflict, and arguments that don't need to happen. The second point really is that, as part of the planning and preparation stage, so like well in advance of anything coming your way or towards an organization, in the what if kind of time frame. run pilots, run trials over, smaller elements of an agency or a portfolio. Try things out, fail a few times, fail forward, build on those successes and lessons learned, and then, scale up to the larger regional and national scale services, once they're effective. That way you have, more resiliency in your resiliency. And kind of what the pitfalls are, what kind of additional supports you might need before you actually have to put them into practice.
Yeah, one of the things from my point of view that I think the public sector could learn from a lot more is how capital investment prepares yourself and actually understanding the value of that. The private sector, I think, does a much better job, Emily, of actually building out a cohesive business case, understanding that an investment now provides risk mitigation later. And quite often in the public sector, we get, the capital budgets are so separated from operational. First of all, they're separated a lot from operational budgets. Second, on top of that, they're definitely separated from any sort of discussion around risk or cost mitigation, right? Because really, when we're talking about risk, it's cost mitigation. It's preventing you having to spend money later. And because those buckets are separated, we're not quite often when we're designing things, we're immediately hitting a barrier of actually putting in more resilient infrastructure because, let's be honest, it costs money, right? Building in resilient, redundant systems costs more. And certainly in that healthcare world, the cost to construct is getting higher. It's outpacing inflation. It's outpacing the cost of construction in other sectors. So there's a lot of pressures to build these buildings. And if we could look to the private sector around having a much more constructive conversation where we're not talking about cost, we're talking about value. We're talking about safety and risk and really looking at it as an investment. I think that's a lesson that could come into the public sector and be much more constructive in the way that we're allocating funds.
Go ahead.
So I was going to actually go a different direction, but Kevin just said something that triggered me. So I think it goes back to, I'd say like one of the key things is Kevin's earlier comment around systems-based thinking and looking at value, not price, is I think something that it's just been eye-opening in terms of sometimes the creativity in terms of what we're here in the US, in Idaho, and we're actually working with, I can't go into details, but a healthcare firm that's looking at how they can most cost effectively reduce their risk or increase their resilience, I'll put it that way. And one of the things that they're asking us to help model out is a lot of the systems-based inputs to their vertical supply of their hospital's needs. It could be drugs, electricity, everything. And what it leads them to do is the way for them to increase their resilience isn't investing in their own physical asset or anything even that's directly under the control, but they're getting very creative around, we know this tech company wants to build this power center. We will help them and lobby for them and even coincide alongside with them because they're seeing how forecasted climate change comes from Jonas's group in that weather team is going to increase, surge capacity, which is going to, the government's going to come back to this hospital and says, you're going to need to have your own power centers under these scenarios. And this hospital's like, hey, if I can convince this tech company to build their power center in my state, not this other state, I can conveniently offload my surge needs to them. Like they're thinking, beyond their own immediate context and finding ways to have creative solutions. And I think that leads to my original advice to government. I think if government doesn't harness the opportunity of all this new data and technology, it's not lack of resources. Government has more money than everyone. They've got some of the smartest, most dedicated, educated public servants. I think public servants are really committed assets to the community. I think the original sin of government not adopting innovation largely comes down to procurement. Because I think a lot of times these procurement vehicles come out and they say, I want you to develop a solution that'll look like this, it'll do this, it'll have these inputs, it'll produce these outputs, you're going to have this long time, you have to charge this amount, and by the way, within that, be creative. At that point, you have completely removed from the picture any ability to evaluate a new way of thinking about things. And I think that's something that it's been a very jarring thing for me coming from government to the private sector and about how oftentimes private sector is, I know what I want. My one metric that matters is increase my resilience in the most cost-effective way possible. Now surprise me. I think that is where a lot of creativity gets brought into the process.
I couldn't agree more.
Yeah,
I wish I thought of the procurement thing.
But It is absolutely true. It's the silo things. It's the CapEx doesn't talk to the OpEx. The CapEx will try to save a dime today and not thinking about the 10 dimes or the dollar saved in 10 years. They don't look at it at all. And that's the same private also. We have the same issue in private. The things that I faced over 30 years working with data center, and keep in mind that some big companies came into the data center market, mainly telco companies, when they came into the new, didn't understand exactly why we would need so much generators and cooling and so on, depending on the type of telco. They had some, but not in the same level and same ways. And they were always asking, what's my return on investment? And the thing is, there's no return on investment on resiliency and redundancy. There's no. What you're building is an insurance policy. So what's your return on investment on the fire insurance you're buying for your house? Absolutely none. It's a pure expense every year, on year, on year, on year. Okay, you just hope you never going to have to use it. So, and that's the thing. So once you can convince them that they're buying that as an insurance policy to make sure that the society, the people they're serving will still be able to go to the hospital, will still have access to a fire station. Okay, when there's something goes wrong, and the telecommunication system will still be up and running, the internet will still be up and running, because the internet today should be, and it is not, but should be still considered critical and for our society. I think this is how we're going to convince them. We need to break the silos down, which never happens. It's pretty hard in private, imagine in public. So
I like that mission where maybe it's we need to rephrase the question, right? It's not return on investment, it's prevention on investment, right? What's my prevention on investment?
Yeah, that's great. I like that one.
Good thing it's recorded.
Prevention on investment.
Okay, well, thank you to all of my panelists here today. So now what I'm going to do is open up the floor to those that are attending our session to pose their questions in the Q&A portion of Teams. And I actually have two already in there. So they must have been typing while you both, or all four of you were answering. So I'll start with the first one. I hope I get your name right. Khadija. You had noted, as you all said, there is tremendous data collected and risks are and always will be there or here. Now, how could be accommodated? Should be changing codes and standards we're using in the building field, because we as engineers always are referred to these codes.
Short answer, yes.
Yeah, it's like I said, for me, a code, when you're designing, specifically in my world, in the mission critical world, it's the basic. It's the base. If you know that you're going to face event, you don't wait for the coach to do it. The problem is, it's trying to convince your customer to go above and beyond. Okay, some of them, like I said, are already doing it in face of, because they know that we're going to hit that 50 degrees Celsius or 45 degrees Celsius in the next few years, if not in the next few months, and they don't want to have issues with it. They don't want to lose data. Losing data means losing customers, losing your reputation and so on. So it's worse. So always try to think a little bit more.
I agree completely. And, I'm an engineer, and engineers in Canada have a duty to the public safety. And if you're aware of a risk that isn't addressed sufficiently by code, you have an obligation, a professional obligation, to be able to design to what you understand the risk to be, regardless of what the code says. As long as that code, like Michel said, is kind of the base, like that's the minimum, that's the backstop, but it's not sufficient in most cases.
Yeah, there's a responsibility to advise, right? And our clients, with all of the things all the pressures that they have, which are there's monetary and there's budget pressures and there's all sorts of things they need to deal with, but we do need to inform them of what the risks are. The reality is codes and standards, get updated on a cycle of anywhere from 5 to 10 years, depending on which code and standard you're looking at. That's the rate of change that we're seeing is moving much quicker than that. we know that a lot of these risks exist. There's a duty to report and advise our clients that those are there, what they choose to do with the information and what they're able to afford to, they're not going to be able to afford a gold-plated 5-foot thick concrete wall box that's going to respond to every single potential threat that's out there. But at least they're informed with information, make smart decisions around how they keep business continuity in those events. And so that's really what we need to do. There's an advisory part of what we do, and then there's an implementation part of what we do. And we need to get our clients the information in order to be able to take the action that they deem necessary for their business.
Awesome. Mark, did you have anything to add, or can I just point out that planners or other municipalities start to add in extra guidelines for certain things? So it made like, okay, you have to ideally go beyond just that minimum code depending on your geography, but then there's all these extra guidelines that start to add more layers of complexity to certain facilities or even the public realm that we're designing for. And so it just, yeah, it gets complicated.
Actually, exactly like Jonas said, we have the obligation to serve the public. More than that, facing a judge, there's codes and there's rule of art. The rule of art. If the rule of art is beyond the code, that's what you should be applying also. And it's as enforceable in court as any codes. Okay, so always keep that in mind.
Yeah, that's awesome.
Yeah, and I think that's the work that UrbanLogiq and WSP are working together on. It's exactly to Michelle's point, where the code is a code. However, for example, working with the climate team and the weather team and all the different geotechnical experts, one of the things UrbanLogiq is doing is we're simulating how risk changes for every community and asset across the country based on 27 different scenarios of climate change. Now, for example, the code may say that a certain facility is built to the acceptable standard, but if using the simulation tool is revealed that the code is insufficient and this asset will fail, even though it's deemed to be critical infrastructure, that's where I think it's useful to have a data-driven, transparent, explainable model so that you can then go to an engineer who they do have a professional obligation to do what's right, for the community, and they're able to say, I know the code says this, but I can factually prove to you that based on all the best science, this asset is going to fail. And we have an obligation to inform the decision makers that the code is insufficient in this scenario, and I can prove why. So I think that's where we're hoping to use the power of data so that it provides an agility beyond a static code approach.
Wonderful. So we have 2 more questions so far that are in the chat. So the next one came from Andrew. I'm going to try to give a synopsis of this one. So he has some work doing critical infrastructure in BC for the federal government, and he found accessing and sharing data is limited or difficult because of security concerns. How do you navigate this hurdle regarding security concerns that can manifest by collating this information, and how can we share widely while addressing security concerns of owners and government agencies?
I would love to take that one. So
that's
a great point. Yeah, it's a great point, and it's oftentimes, I think, the biggest issue on having this consolidated data picture, particularly in the government, is not technical, it's organizational and bureaucratic, and for very valid reasons, right? There's governments deal with the standard of care of their citizens' data that is I think above and beyond what the typical private sector company would have to deal with. So they're very legitimate things that we can't dismiss. And so one of the things with UrbanLogiq, when we formed the company, we formed the company explicitly to serve governments and only governments. And so because of that, from day one, we architected the platform in a way that has federated data access levels. So what that means is whenever data goes into the system, you can define who should have access to not only this data, but what features and details within the data. And then every year we're annually audited. So we have both privacy and cybersecurity certifications that we voluntarily subject ourselves to audits. And we've hosted data for everything from the Federal Department of National Defense to local police departments and everything in between. Private sector data from credit card information to cell phone location or location like GPS signals off of cars. And each of those cases, we had to prove to the data provider that their data would be only available to the appropriate persons approved by the data owners, and that it could only be used for the purposes that they deemed appropriate. So I think that's one of the things is before you ask for people's data, you have to build a structure that is provable and auditable, that shows that I can ensure that you have control and rights over any data that you share. And then I think after that, you have to establish that trust by design. And then from that point, I think it is a duty of care, both jointly between the data hosters and the data owners, to make sure that we're on the same page around why you're sharing your data, who it's allowed to be shared with, and as long as that can be transparently disclosed to all stakeholders, you create an environment where people are free to share with what they're comfortable sharing.
Great. Thanks. We have another question came from Iveta. So she was saying that we were covering how there's the need for conversations between levels of government and private asset owners, but what might it concretely look like to break down the barriers caused by disjointed ownership of assets and data proactively? And how could we incentivize long-term planning? Which I feel like is complicated because I was just at a housing summit last week, and it was municipalities and developers to kind of solve the housing crisis. And they all talk about collaboration with each other, but I feel like they're promoting it, but I personally don't see enough of it actually happening. So I'd be really interested to see what each of you think of how we can incentivize that a little bit more long term.
I'll start with an example. So there is a city that we're working with where they put all of the city data into our platform, and then they gave us permission to go to the county and the state and the federal government and said to those different levels of government, please contribute all your data with these proper controls to the platform, and here's the use cases. And then once we had all the data in one place, the key thing is the city defined in advance why they wanted the data. It's for long-range planning purposes, for equity, sustainability, public safety, and then certain different data sources, were identified as contributing to that. And then what would happen is, for example, it might be identified that the city doesn't have road sensors in a given area, and so they went to car manufacturers and said, here's what we want it for. Here's what we're going to do with it. And then those car companies provided the GPS signals of the cars under proper privacy constraints that were approved by both sides. And then I think one of the things then is they went to the local business community and said, we need to understand how you're recovering from COVID and the like. Here's information that we would like from you. And if you share it into this platform, you will also benefit because you'll get an insight of how the community is evolving in terms of demographics, shopping patterns, etc. So the incentive, so I think the actual use case was everything from cell phones to cars, road sensors, cameras, tax information, 911 calls were all shared into one platform with the proper governance controls and restrictions. And then they went to the private sector and said, you can share this data, get benefit of insights, or in some cases, the government will pay for your data. So there is incentivized both that they'll get benefit from an insight. And also, if you happen to be sitting on this data, you can actually monetize your data within a proper privacy and controls constraints. So I think that's an example of a very exciting project we're working on where everyone has come to the table with a goal of building a system that the government is able to simulate what basically called policy impact analysis. If we were to build a road here, or if we were to switch from buses to light rail, how would this impact poverty, climate change, etc.? And everyone in the community was invited to participate, but transparently, before they were asked for their data, it was explained, here is what we're going to do with it. And in fact, we had to send our team to testify at a number of televised sessions where they brought in outside privacy experts, legal experts who would grill us in front of the public before they were accepted as, okay, this project is allowed to go forward. So I think that is an example of how it can work, and it worked beautifully.
Okay. Wow, that's a lot. Thank you. Hopefully, we can take that away and start applying it some more and replicating that example. So our next question, and we're just about time. So I'm not sure, panelists, if you can stay on for a few more minutes just to answer the last two that we have. So the first one I think is probably for you, Kevin. A critical point of failure for hospitals often occurs after a natural disaster when external support and supplies are delayed, as seen in New Orleans. How can artificial intelligence be leveraged to improve changing point of failures during recovery efforts and/or planning in the aftermath of natural disasters?
Yeah, it's a really good question. It's it's not even just in New Orleans. If we look at the COVID pandemic, here in Canada and in the United States, lots of issues around PPE, lots of issues around supply chains, which really slowed down a lot of the response and impacted the ability to care. So, I think what we could utilize that for in a really productive ways. First of all, using it to understand where those supply chains are coming from, right? So who's manufacturing the supplies? How are they getting to hospitals? Where are the stores? So once they do have them, where are things being stored? And then there's what the hospital has, but there's also what emergency response professionals, what disaster response at the federal level, where are they storing their materials? Where does the private sector have certain supply chains and stockpiles, right? And so step number one is first of all finding out what you have and where is it located, and then step number two is utilizing AI to figure what's the best way to get that equipment from point A to point B when that failure happens. And it's especially critical to leverage that, I think, for rural areas, right? So when you take a look at some of the disasters we're talking about, like wildfires, wildfires impact communities quite disproportionately, impact communities that are more rural, have smaller populations, harder to reach, and less access to infrastructure. So I think there is an opportunity for us to look at where are things located in our large urban centers, where there's typically more of those supplies, and then what are the routes that we could use in order to actually get those materials to the areas that need it the most. Actually, Mark, and I don't know if you've got any insights from a data point of view, because that's what I see from the client's perspective in terms of where the hospitals are that are responding. But from a data point of view and where we're leveraging that, I'm not sure if you've seen examples of that.
Actually, if I may,
or Michelle,
I think we could learn from AWS tremendous, biggest distribution system in the world. Okay, the way they're doing it with their warehouses and so on. Their warehouses are stuck in a really, 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 really strange way. They have peanut butters everywhere. That will be mixed up with coffee cups and things like that. Why? Because they know exactly what's being ordered with what, and when the robot goes in, it takes the shortest path possible to pick up the things. So not all the peanut butter and the breakfast things will be at the same area, and the equipment will be on the others, because it's going to have to cross that 1 million square feet thing to go. So if we could apply that same model within the community with multiple things everywhere in smaller warehouses and so on, we could have multiple paths possible to, especially in case of emergency, to shorten the last mile, to make the last mile faster. And that's the goal of AWS. The last mile is faster all the time, and actually within their warehouses it's better. I think that's something we could try to apply in there. We're not there yet.
We're working on it, and that's actually what Michelle describes is actually the exact thing we're working on. What Kevin was alluding to is we're looking at the one metric that matters. So think of it as return on prevention and return on resilience. Come with that metric, and effectively what's happening behind the scenes is once you have this causal map of how everything in the community relates to each other, we're simulating billions of possible combinations to find out what is the most efficient way to maximize that output. And I was saying, I was hinting at, I think some of the stuff we're going to reveal with WSP. Sometimes there's surprisingly creative ways that we can help the government do more with less.
Awesome. Okay, for our last question then, the operations budget versus CapEx budget question has become something I've heard come up in many conversations related to climate change, risk, resiliency, et cetera, and really all sorts of other policy related challenges. Are there solutions being explored for this?
Yeah, actually the easiest one is TCO, total cost of ownership. They should never be, when you're building a project, when you're building something, they should never be different budgets. There should be only one, which is called total cost of ownership. Over 10 years, 15, 20, or 25 years, depending on what you're building, that's the only way to go. This way, you're going to invest the best money to build out. That's going to save you the most money on operation. Especially it's probably the same thing for a hospital, but in a data center, I don't know for a hospital, but in a data center, 40 to 60% of the total cost of ownership is power. It's energy. 40 to 60%. Okay, it's going to be even worse with the AI coming in, but it is. So anything you can build and invest a little bit more money to save over that 20-year period, even if you save 2 or 3%, that's a tremendous amount overall. So we need to stop. Customers, government need to stop thinking about, and I've seen so few projects coming out. We need to know the total cost of ownership of your design. So,
Michelle, you're setting me up for a whole other webinar. It's again, in my mind, it's also the people, like on the healthcare side, the biggest cost is people, right? It's HR, it's nurses, it's clinical staff, and what we definitely don't do is have a conversation around how design decisions will actually retain staff. How does it stop burnout? How can you actually invest in your capital in order to make your people's lives easier and therefore lower your costs for people? And there's so many things that feed into that. But what it requires is strong leadership to make those types of changes, and it requires good access to data. If you think sharing public-private data is hard, like try to get access to HR data, anonymized HR data that helps you make smart design and infrastructure decisions. It's next to impossible, but you need to be able to get that and feed it into your design process in order to design smartly. Right? That's where we need to head.
So break a mold, and then you're going to have to face the public opinion. Because you're changing the way because
it's tough. It's tough.
On day one, the hospital was supposed to cut 500 million, but saving 800 million over 20 years is going to cost 540 million or 600 million dollars. That's a cheap hospital, by the way, really small clinic. But
I'd love to build one for that.
Yeah. So but that one is going to the $500 million is going to cost you like $75 million more overall. So, but the only thing that will get out to the public is how much we're going to spend right now, and that's the thing. We need to. Education is the number one problem for any public. Like the best view, we're not viewed really nicely, the data centers now, just because of bad education of population. That's another story. I could do a full hour on that. So
we have 2 more webinars lined up now.
Yeah.
Okay, well, a special thank you to my 4 panelists here today. It was such a pleasure getting to know your industries a little bit and really getting to know the nuts and bolts of natural disasters and how your industries are dealing with it. And also a big thank you to those that were able to attend our webinar today. It will be sent to you as a recording, and we will also be putting it up on the WSP YouTube page for those to revisit later on. So thank you again, everybody, very much, and we'll see you another time.
Thanks everyone.
See you, everybody. Bye. Bye.